All right, hi you guys. So this is going to be for 5th grade. This is your math lesson for today, March 18th. It is lesson 16 in module 5. However, I would like to invite everyone to do this, even 4th grade. It is a great lesson on shapes, angles. I really wish I was doing it in the classroom, but what can you do? So let's start on page 111. 4th grade, you guys can kind of skip through this application problem. I'm gonna go over it with 5th grade, but once you start seeing like shapes, materials, you guys can always get just a plain piece of paper and do a lot of this with us. So let's get started. And don't forget, I'm gonna constantly remind you just to pause the video to work out the problem. So let's start with our application problem. Kathy spent 3/5 of her money on a necklace and 2/3 of the remainder on a bracelet. If the bracelet was $17, cost $17, how much did she have to begin with? So first thing I think of is 3/5. Like anytime I think of something like that, I think of a tape diagram. So what I did was draw out fifths. 3/5 was the necklace. We don't know how much she spent on the necklace yet, but we do know that 2/3 of the remaining was the bracelet. I think I forgot an E, by the way. This is definitely not, oh, hello hand. This is definitely not a spelling lesson. Bracelet, there you go. So you have 2/3 that are left. Now, I had to break this apart because if you think about it, 2/5 was left, but we got to break up each one 2/3 and 2/3. So it's really 4/3, if you want to look at it like that, or 1/4 of 5th. So I'm going to take that information right here. $17 will be represented as 17. I got the 4 because it was 2/3 and 2/3 of what was left. So I'm going to divide it by 4. Here's a few different ways you could see it. 17 over 4, 17 divided by 4, $17 into 4. So start doing the division. Okay, so that 1/4 of each part of that bracelet was $4.25. Kind of important because then we have to multiply it by whatever the necklace was. Now the necklace, you're probably going to think of, how did she get 15? Well, you have 3 of 5, 3 of fifths. Well, if you multiply that, what do you get? 15. So you're going to take 15 and multiply that by $4.25. Oh yeah, don't forget to follow me on YouTube. Might as well. All right, then I did all of my math. I multiplied $4.25 by 15. Again, 15, we got to find the difference of that necklace. That was the 15 and the bracelet. So we got to see what they're all together. And it should have been $63.75. That's what she first started with. Which, if you ask me, why didn't she have $64? But there you go. That's our math problem, our application problem today. So again, you could pause this and see all my different arrows to try to explain it. Now, here's going to be the fun part. So we are actually going to be drawing trapezoids and classify their attributes, and then define trapezoids based on their attributes. So you guys are going to first see what I'm going to do. Let me give you the list of materials you will need. So scissors, ruler or a straight edge, and a protractor. A protractor is that thing that measures the angles. I don't have one. I don't even have one. The whole set is in the classroom. So we're supposed to do this in the classroom, but I have a solution, even for me who does not have one. Okay, so you actually need to rip out 2 templates. The 2 templates are page 119 and page 117. There's all these shapes. So right now, hit pause on the video and cut out all of the shapes on page 117. Pause. Make sure you follow and subscribe to Jennifer Carey on YouTube. I'm gonna start plugging. This is how I'm gonna become a YouTuber, like teacher YouTube. All right. So here is our solution, what you're gonna do. Again, if this is 4th grade following us, you guys can get a plain piece of paper, and we're actually gonna review our angles. Since we do not have a protractor, we're gonna be reviewing our angles. So let me get my pen, and we're gonna start with a right angle. If you remember, a right angle is exactly right here, is exactly 90 degrees. So that's why without our protractor, we can actually determine which angle is which. Because on the next page, 5th grade, on page 114, it says that we have to measure angles. Well, we don't have our protractor. So what we're gonna do is actually label. Is it a right angle? Obtuse. So when I teach this always to 4th grade, I always say obtuse. It is bigger. It is larger, so I'm gonna say greater than 90 degrees. Remember, greater than 90 degrees. One day with making all these videos, I'll probably get really good at holding my phone steady so you guys can see. And acute is actually smaller than 90 degrees. So remember, smaller than 90 degrees. And the way I always do this to teach, I'm always like, oh, so cute. You're so cute. That means this angle right here is smaller than this. And then I say obtuse. Obtuse is like a big guy. Like we should have named Samson an obtuse angle. He was a big dog. And then hopefully you guys know what a straight angle. Straight angle is exactly a flat angle, straight, and it equals 180 degrees. So that will help. So make sure you guys have these all written down. Sorry about my obtuse. He's not a pretty one. Now, our next step is to define what a trapezoid is. So again, 5th grade, I'm going to stand up so you guys could see. 5th grade, this is on page 119. And our whole target today is to learn what trapezoids are. Well, in order to know what a trapezoid is, you need to know what a quadrilateral is. So trapezoid is actually a quadrilateral. Quad means, hopefully you guys remember this, 4. So it has 4 sides. 1, 2, 3, 4. Even the outside of quadrilateral is 4. 1, 2, 3, 4. Do you guys see that? So go ahead and write down the definition. It's a quadrilateral, and it has at least one pair of opposite sides. They're parallel. And that's actually going to be our first part of our problem set. We're going to actually be drawing parallel lines. That's our whole focus today. And then it says we need 2 obtuse angles, 1 obtuse angles, at least 1 right angle. So we're just going to be drawing and answering questions. That's going to be our whole target. But I wanted to have fun. So we have all these shapes here. The only thing I don't have is a glue stick. So I'm just going to kind of place them over here. And if you guys have glue, we're going to glue them down. We're going to classify them. Classify them means you're putting them in either one area. Is their name called a quadrilateral, trapezoid? Remember, these are actually kind of the same. Or is it a non-quadrilateral? I had to abbreviate. And then even right here, I'm like, what does quad mean? 4 sides. So start going through all your shapes. Again, you can pause the video and see if you guys get these all right. So I'm just gonna go ahead and start this. I noticed this has a lot of sides. 1, 2, 3, 4, 5, 6 sides. Cannot be a quadrilateral. That is a non-quadrilateral. This one has 4 sides. Ooh. But then you need to determine, is it a trapezoid? Trapezoid has 2 parallel lines. So if I had 2 hands right now, which I only have 1 hand, if I kept drawing these, they're actually going to intersect. So that would just be a quadrilateral. Quadrilaterals can actually intersect. So then let's look at our next one. This one actually, the letter H, has 4 sides, but it's very weird looking. So I'm going to kind of push that to the side right now. This has 4 sides. 2 of them look parallel, these 2 on top. I think I'm going to put that in trapezoid. So do you guys see what we're going to do? We're going to classify them right now. Letter D. Do you guys see? Letter D. Ooh, that has 4 sides. They actually all look parallel. I'm going to put that under trapezoid for now. If you look at F, I see 4 sides. None of them really look parallel. I guess these 2 could, but I'm going to put that here for now, a quadrilateral. This one looks like a square or a diamond, so it could be quadrilateral. Oh, look at this one. Look at M. I see more than 4 sides. That's a non-quadrilateral. B, it's quadrilateral. There's 4 sides. A, perfect rectangle. I'm gonna put that over here. And again, it could go into trapezoid. Trapezoid, the definition was only 2 of them have to at least be parallel. That to me looks like there's 4 of them that are parallel. What about N? 1, 2, 3, 4. Has 4 sides. I don't think I would call that a quadrilateral though. O, nope, non-quadrilateral. What about L? What do you guys think? Count the sides. You're right, non-quadrilateral. Very nice. And then how many sides does this have? That's a triangle, so non-quadrilateral. What about C for Carrie? 1, 2, 3, 4. Oh, I see 5 sides. Non-quadrilateral. Now let's go back to this H. What do you guys think? I do see 4 sides, but like this part right here, this wouldn't be intersecting. So that's why I'm going to kind of classify this as non-quadrilateral. All right, very nice. So I'm actually going to stop this. This is part 1 of lesson 16. Part 1. Part 2 is our next video. That's going to be us, 5th grade, actually doing the work. So make sure that you guys have a ruler or a straight edge. A straight edge would always be fine. Like I could always take my Post-its. Mr. Carey in his office desk actually had a ruler. So I kind of lucked out. He did not have a protractor though. So see you guys on part 2.